volumetric analysis. By means of volume, you can measure the concentration or you can estimate the strength of a solution. So titration is nothing but the determination of a particular the concentration of an unknown solution using the standard solution. When I say standard solution means we have got the concentration already. Are you will follow? And we have already discussed about the various expressions for concentrations. What are those? Percentage, that is the preliminary level. And then we have normality, molarity, mole fraction, etc. So here we are using molarity and normality. Let me explain about the titration process also. Now you've got the burette. It is a cylindrical tube with the stopcock assembly here, where you've got about 50 ml capacity. So it is a long stem cylindrical one. You've got the graduated cylinder that is called burette. And you've got the standard flask, the conical flask. And apart from that, you've got the standard flask like this with a long stem and pear-shaped bottom with stopcock arrangement. Stem cap arrangement. And there will be a marking also. So you have to prepare the standard solution here by weighing certain amount of quantity. Based on that, once you know the weight of the salt and the volume of the solution, then you can arrive at the concentration of the solution, and that is the standard solution, known solution. That is the solution of known concentration. Do you understand this? Right. So, for example, you've got we can titrate between two reagents like chemicals like potassium permanganate can be taken in the burette, and you may take the oxalic acid. Along with that, you can take 10 ml of sulfuric acid in order to make it acidified one. Now, on adding potassium permanganate, what happens? It is reacting with the oxalic acid, right? So it is a redox titration. It involves reduction and oxidation. That is, it involves oxidizing agent and reducing agent. What is the oxidizing agent? We have taken KMnO4 as the oxidizing agent that is in the burette. And you got the pipette, we take 20 ml excuse me, of known solution of oxalic acid. And we can drain here, then put some sulfuric acid, and you can also heat it. Now, listen, here you can drain this burette after filling up completely up to zero marking, that is 50 ml marking. So here it is a 0 and it goes down like a 0 ml, 10 ml, 20 ml, 50 ml like that. So by opening this tap, you allow the burette solution draining through this burette, right? And at certain stage when the reaction is completed, that is called endpoint, so that you know the actual quantity, that is by volume, required to oxidize this oxalic acid present in the system. Are you able to follow? So this is known as redox titration. Let me assume two or the oxalic acid, one or KMnO4, potassium permanganate. Okay. Now the titration equation is this one. That is, on the right side you have got the oxalic acid, on the left side you have got the potassium permanganate, right? So the product of molarity of potassium permanganate and volume and its valency factor is equal to the molarity of oxalic acid and then V2, the volume of oxalic acid, then E2, the valency factor. So based on that, you can find out the unknown concentration. For example, let me say we have taken 20 ml of oxalic acid of known concentration, say 1 molar, like that. And we have got around 19.6 ml of KMnO4. Okay, now let us fill up this. We have got the equation here. What is that? M1 V1 E1 is equal to M2 V2 E2. Got it? So we already know the molarity of M2, that is oxalic. This side oxalic acid, this side on the left hand side you have got KMnO4. So what is the value of M2? 0.1, okay, molarity. And what is the volume of V2? V2 is nothing but oxalic acid, that is the pipette volume. We have taken 20 ml, right? Got it? 20
Yes.
ml. And what about the valency factor of oxalic acid E2? What is oxalic acid factor? 2. Why? Because two electrons are transferred here. That we already discussed. Then what is the molarity of, so these are all known. And the valency factor of potassium permanganate, how much? It is 5. Do you know why? Because Mn 7 plus becomes Mn 2 plus. That we already discussed under what? Redox reactions. Okay, so 5 electrons are transferred, so we put 5. So this is also known. And the V1 is the titer value. The titration value is 19.6. This is the experimental value. Okay. So by knowing this, you are able to find out the M1, is it not? The molarity of the unknown, concentration, is it not? So M1 is equal to what? M2 V2 E2 divided by V1 E1, right? So that is equal to, what is the molarity of this much, oxalic acid? Zero point 0.1. And this is 20 ml. So since both of them are 20 ml, you can maintain that. Otherwise, you can convert into a liter also. So let us make it 20 ml. And what is the valency factor of E2? 2 divided by volume of KMnO4, that is the titer value, 19.6 into, and what about the valency factor of KMnO4? 5. Get me the value.
1.020.
1 point.
020.
Now please check once again.
1.020 M.
Is it correct? See, this is how much? 4 times. Okay. So 4 twos are 8. So zero point 0.8. 0.8 divided by 19.6. Tell me.
0.04.
0 point.
0.
Check once again. 0.8 divided by 19.6. 0.41.
1.
Let me
Yes,
check.
because 0408.
0.8 divided by 19.6 means 0.0. Okay. So 0.04, you can put 1 also. Okay. So this is the molarity required for KMnO4. So do you understand this? Okay. So this is called the titration or the volumetric analysis. Okay. So, and when you dilute, you are able to get a different molarity, because the dilution on dilution, it will change. So this is the dilution formula, M1V1, that is of one concentration, and it is further diluted means then the diluted solution will be having the third one. So likewise, this kind of titration techniques are very useful in determining the unknown concentrations. Okay. So I will give you some of the worksheets based on the uh, titration. Okay.